I'm Bob Cowan. I'm the Director of Facilities and Facilities Engineering here at the Fred Hutch Cancer Research Center. My primary job is to run the fantastic team of facilities engineering as they run the facilities, okay? It's a big job. We're a 1.6 million square foot campus. It's a complex job. Some people said we're more complex than a nuclear power plant because of all our labs and everything. And it's a demanding job because we are a 24/7 operation, meaning that we're here 7 days a week, 365 days a year, 24 hours a day. So we got a very demanding job in a very demanding environment, and we got a great team that does it. We got a couple of philosophies here, okay? One is, if you don't have a good plan B, you better have a good resume. But things still happen. So we like to say, every cloud has a silver lining. We try to learn from past failures and make sure we don't repeat them again. My background is, I was in the Navy for 22 years. I went to undergraduate school at the University of Michigan, joined the Navy, spent 22 years in the Navy, and the Navy sent me to graduate school at the University of Florida. But when I retired from the Navy, I got married and I had 3 kids I had to put through college. So I decided I'd get another job, and I'm very happy that the Hutch hired me because this is the greatest place in the world to work. It's a complex place, like I said, though. We've got over 105 air handlers, and we move 2 million cubic feet of air a minute. We got 60 different water systems, okay? We've got 15 big boilers, and we got 8 generators that can produce 9 megawatts of power. And we're going to start our tour here with our computer-based system that runs the campus, okay? From my desk, I can go into any building, I go to any zone, and I can see in real time what the temperature is in that space. And then if something's not right, I can look at the fan-powered box serving that space. I can see what the discharge temperature is coming out of that box. I can see where the reheat valve is. I can see how fast the fan is going and how much air is coming in and what have you. I've got a lot of information at my fingertips here as I try to troubleshoot a problem. We've got 10,000 pieces of equipment hooked up to this. And if any of those pieces of equipment aren't working right, a red line comes in on our alarm screen letting us know something's out of parameters, and we can go out there and diagnose the problem and see what's happening. One of the great things about this program is it's a lot of people call it a building automation system where we automate the building, but it's also called an EMCS, Energy Management Control System. And this allows us to control a lot of energy. So we've got different programs that optimize the energy usage. You know, here again on our air handlers, you know, we look at optimizing the discharge temperature of the air handler. See, right now the discharge temperature is 62, and that minimizes how much energy we have to do to heat and cool the building. So there's a lot of optimization programs we use to minimize the amount of energy that's used in this building. But again, there's 10,000 pieces of equipment that's hooked up here, and if any one of those pieces of equipment goes into alarm, we get a red line. Problem is, in an emergency, everything becomes a red line, and you lose what we call situational awareness. So that's why we got this yellow submarine here. We click on the yellow submarine, and we can see at a glance all the systems that are green, any system that might be yellow, and any system that might be red. So we know in an instance if there's an emergency and where we have to focus our attention. We don't have enough attention to focus it across 1.6 million square feet. So we got to focus it on critical systems and critical areas in a timely manner. So let's take a look and go out and take a look at some of these systems. I mentioned we had a lot of equipment on this campus, over 10,000 pieces. Some of it's pretty big equipment. This is called an emergency generator. When the lights go out, this emergency generator kicks in and still gives us power to the building. This is a big emergency generator. This is 2 megawatts, right? We've got 8 generators on campus. They're not all this big, but between the 8 generators, we can do over 9 megawatts of power. That's enough to power a city of about 8,000 homes, okay? 7,500 to 8,000 homes. So we can run a small city from here. This is some of our switchgear room. These are the automatic transfer switches, and they detect normal power. If they don't detect normal power, they would turn on that generator and they would transfer the load, that's why they're called transfer switches, over to that emergency generator in less than 10 seconds. So the lights will be out for 7 or 8 seconds, and that seems like a long time, but it's actually a lot of things that have to happen from starting that generator to transferring the load in a very short period of time. This is our famous interstitial space. When you got 60 water systems, you're moving a lot of air, it really helps when you're servicing your lab, you have an interstitial space above it like this. So you can quickly make repairs, you can quickly make alterations and what have you. Now, every one of my peers from around the world that have been here said, Bob, this is fantastic, this is incredible. If only we could afford to do this. And I tell them, you can't afford not to. And they say, yeah, we get it. We know that there's, a life cycle cost that makes this practical. I say, no, there's a first-time construction cost that makes this a very cheap way to go for lab building for a couple reasons. One is you can see how nice and long and straight the pipe runs are and the duct runs are. There's not a lot of elbows and all. The construction crew is working at ground level. They're not working off ladders and lifts, okay? There's zones for your network cabling, for your piping, for your ductwork, so you don't have a lot of trade conflicts. But the 2 biggest reasons might be that A, you can have your electrical mechanical team up here working while your architectural team is working in the lab down below, and that allows you to compress the construction cycle, and you can put a lot of small but still space-intensive equipment up here in the interstitial. You can see another advantage, okay? We can make modifications and alterations up here without disturbing the research going on down below. That's very important for the scientists. They don't want to be disturbed. And I mentioned we had a building automation system that controls the campus. We got 4,000 computers embedded in the walls, okay? You got to keep this stuff up to date. You can't let it go to pot. And so we have a philosophy, we'd rather replace a piece of equipment a year too early than a year too late.
So my name is Pat Nolan. I'm the lead engineer for building controls. And we monitor basically the whole campus, freezer alarms, refrigerator alarms, building automation, HVAC, the fire systems. We kind of do everything across the whole campus. So if you ever have a temperature call, we're the ones that get that call. There's over 2,000, I think, refrigerator freezers that we monitor, and then quite a few that we don't monitor, but we still respond to. And then there's over 10,000 pieces of equipment that we also monitor on a day-to-day basis. So everything that controls the zone that you work in, there's a little tiny computer up there controlling everything. So we can monitor and control that right from the front end right here. There's actually servers right behind you here that run a program that we use called Insight. It's Siemens. It's a Siemens product. And we can remotely log in and see your room and control pretty much everything that controls your zone. Heating, cooling, airflow, we can adjust everything. So I started high school up on First Hill next to the old Fred Hutch building. So I kind of saw Fred Hutch, across the street from me. So it's always kind of been interesting. And then I didn't know what to do, so I went to the Army for 8 years. Went to Iraq and Korea and Germany. And then came back to the United States, and I started off actually in security here at Fred Hutch. And then an apprenticeship opened up for engineering, and so I was lucky and I got into the apprenticeship. And the apprenticeship basically is 4 years long. It sends you down to Renton Technical College to get all your book, your class training, and then you work 40 hours a week in the trade here at Fred Hutch and learn everything about every single department that we have. So electrical, mechanical, controls. So.
And then after that, you should choose the area that you're interested in?
So you don't really get to choose. You kind of figure out what you enjoy, and then it's kind of the needs of the hutch, whatever they need at the time. And luckily, there was a spot open up in the controls, and so I shifted right into that spot. And then I got extra training while I was in controls. So Siemens has classes that you have to go take in Bellevue, and so they're week-long classes that basically train you about everything on the back end of this control system. So here's kind of what is always up for security. So 24/7 security can see that any alarms that are coming in. So they're always monitoring the system along with our freezer system. They're actually both the same exact system. But we could see what's going on down in cell processing. So this is our cell processing graphic. We could see cell processing is the clean facility down in DE level. And we could see exactly, if pressures are off or if anything needs to be adjusted, we can remotely adjust it from here. But we can see if there's any issues going on and instantly fix anything that's happening. We could also see the air handler that controls cell processing. So we could see the fans are on, we could see what speed they're running at, we could see if it's in heating or cooling, so no cooling, it's pretty cold outside, 40 degrees. We could see the exhaust fans for cell processing also. We only get 1 week to get into cell processing to do any maintenance we need, so this is really important to keep it up and running for the whole year until our next maintenance cycle. So that's a big one. But from this main graphic here, we could basically go across campus. So we can go up to Seattle Cancer Care Alliance and we can look at what's going on up there on all the air handlers. We could see PHS building and all of its air handlers. So it's really a very interesting system. We can go over to the data center at Eastlake. So Eastlake has the huge data center that we can go in and verify our airflow is correct and our temperatures are doing what it's supposed to be doing to keep the servers cool. So my boss, Bob Cowan, asked me to build a system that we could see quickly. So in a normal power outage, there's a ton of alarms coming in the alarm screen. It's so hard to figure out, what's critical, what's not critical. So he asked me to build the Yellow Submarine. So basically it takes all of the critical facilities across the campus and then figures out if that alarm is critical or just, maybe it's just a warning. Or we could see that the generators are running. So this is a quick overview of the whole campus and to make sure all the systems are running properly. So everything's green, so we don't have to worry. So a lot of the time you can fix it from here or remotely on a laptop anywhere across campus. There are some big things that that do require you actually to go out in the field and reset them on an air handler or hit a manual reset on a boiler. So but most of the things you can remotely fix right from here. There was a water treatment facility in Seattle that they lost power and they couldn't respond to all the alarms because there's so many alarms coming through. They couldn't figure out what was doing, so they actually dumped a bunch of raw sewage out into the sound. So then Bob came up with this idea okay, we have to know what's going on in our critical facility and get things back up and running.
If you mess something up,
how do I recover from it?
Yeah.
I don't know, it's sucking it up, I guess, right? You take it, yep, I messed up, and then you move on. You learn from your mistake is the big thing. You don't ever do that again. But a lot of the help around here, if you do fail, there's a ton of people that have already failed before you, and so they're happy enough to say, hey, I've messed up before too. Like, you just got to deal with it. You deal with people kind of giving you a little bit, of a hassle, but then you just move on. And here's the boiler room. So this spans all the way down through to the loading dock on the Weintraub. So we're completely underneath the main hall and then all the way down to the Thomas building. It's all connected to one large room. So we have 5 hot water boilers, 2 steam boilers, and 5 chillers all connected here. So we can run just one side in the summertime for heating, because that's all we need is just one boiler, and we could feed all the hot water down to Thomas side. And same with chilled water, even when we're in cooling season. So in the summertime, we can run the more efficient chillers on the Thomas side, feed water all the way back over to here for Weintraub. So it was a huge project. So this is the steam boiler. It supplies 60 pounds of steam off into the system. So all of Weintraub, Hutchinson, and Thomas buildings. And this is mainly used for autoclaves and then humidification for the vivarium. So in the summertime, if you came into this room, you'd have this huge 100 horsepower pump pumping water all the way to the rooftop to cooling towers, running it through the chiller, which is a 600-ton chiller, which is screaming like crazy. It's got this massive motor on top, which is then cooling chilled water all the way for the whole building. So every single air handler it feeds chilled water to. So all the piping, you can read it down here. So here's the chilled water side on the left. There's the main sprinkler line for all the fire systems. Here's low pressure condensate. So this is when steam condenses, we bring it back so we don't have to reheat domestic water. Then we have our normal hot water fed from the boilers, and then our high pressure steam. So that's 60 pounds of steam in that line. A lot of piping, a lot of wiring. So we maintain it all 24/7. We always have engineers here on campus. There's always 2 engineers running the whole campus. So now I'm remotely connected into the front end server back in the control room. And if I'm working on a piece of equipment, I could basically go in and find a graphic that's been created for it. So now I can see our 3 hot water boilers, so boiler 2 is firing. I can see our temperature, 179, and then I can also see our firing rate, so 26, 28. So basically I can remotely monitor this boiler and just verify it's actually working properly. If it is, then I can move on and troubleshoot the next item. So this is called a fire tube boiler. So what it does, we're burning gas, or we can burn diesel, and we'll send it through the fire tube, and it will circulate around, and then it will warm up all the metal around it. If we were running on oil right now, that'd be so bright you wouldn't even be able to see into it. And then what that happens, after it goes through the main tube right here, it bounces off this back wall, sends it back through more tubes, bounces off the front wall, comes back, sends it through more tubes, bounces off the back wall again, and then up and out the stack. So this is air handler B2. It serves the vivarium in the BE area. So you could see the steam that we're actually humidifying for the vivarium coming through. That's coming off of that main steam boiler. So it's crazy to think about, but this massive section, we completely control everything. So we have fans in the front. We can see the filters before them. We can make sure the filters are okay, they're clean. And then we have hot water coils. We have a heat recovery coil that we use, chilled water coils, and then the steam. And we can completely control everything. Yeah, that one's pretty cool. So I think one thing that, coming out of high school, I wish somebody would have said, hey, you don't have to go off to college right away. You could try a trade, because a lot of the trade schools, they'll actually send you off back to college, but you'll also be learning a skill and you'll make money at the same time. Whereas if you go off to college, you're kind of in college for 4 years, hopefully, maybe 5 or 6, depending upon who you are. But learning a trade it's amazing because you're getting paid to learn this. You're working as you're learning it, and you're making money to pay for your everything. So, I wish I would have looked at the trade sooner than having gone to the Army for 8 years and then come back out and say, oh yeah, I guess I should learn. I should learn a trade. You will have to go to some school, some college, but a lot of it's hands-on and it's really fun, and it's hard to do it sometimes too. It takes a lot of thinking involved.
My name's Amber Powell, and I'm a stationary apprentice engineer.
And what does that mean, a stationary apprentice?
So we're the people who work inside of the buildings, like how construction workers work outside the buildings. So we work on all the equipment inside buildings, and some of the stuff outside, like cooling towers. All the stuff that controls like heating and cooling inside buildings.
And you're in the apprenticeship program, so
Yes.
tell me a little bit about that.
So it's a 4-year-long program where we go to school during the nighttime, and then we're on the job training during the day, Monday through Friday.
So you get paid while you learn?
Yes, correct.
And how far are you along in the process?
So I'm a little over 2 years. So after the 4-year program, if there aren't any openings, we're just kind of a floater. So whichever department needs us, that's where they put us, usually. A lot of us have preferences, but it just kind of depends on what's open at that time.
Do you have a favorite? What's your favorite thing to work on?
I like controls. Yeah, it's just so much to learn,
So there's a lot of the computer
Yeah, and you're just like controlling big equipment at the click of a button is pretty cool. So I came from security, and it was really just being around like other engineers and seeing what they do and working closely with them from the security point of view, I guess.
Did you have to apply to the program? What's that process like?
Yeah, I had to apply. I just found on like the classifieds that they were hiring for an apprentice engineer, and I was like, oh cool, why not give it a shot, try it out. Yeah, it was an interview process with a majority of the lead engineers here. So this is an interstitial space above labs and offices, and a bunch of TECs are located up here, which are terminal equipment controllers, and they control airspace in labs and then offices. And then we have electrical panels up here too. Lighting panels. This is a motor that can, yeah, it's a motor that controls one of the fire doors. So that's a lighting control panel. This panel probably controls the first floor, but there's several lighting control panels on each of the interstitial spaces. I think the next class coming up is a boiler lab. So it kind of just like prepares us for our boiler license tests.
So you have to be licensed in different areas?
Yeah, so watch standard is the guys who kind of work on the weekends, and they have to have boiler grade 3 or a grade 2 license to be able to check and do rounds on the boilers.
You get licensed and then you learn more and then you get a better license.
Yeah.
You learn more. And
You have to have experience, and then on top of that, school time.
And then as you get those licenses, your pay grade goes up also?
Correct, yeah. Every license you get comes with a pay increase, usually. Like for boiler licenses anyways. We have a bunch of licenses that will give us a pay increase.
So you're always,
Depending on the trade, yeah.
you're always learning.
Yeah.
Is that a fun part of the job, or is that?
Oh, for sure. Yeah. If this is interesting to you, if this kind of work is interesting to you, then absolutely.
You're always learning.
Yeah.
That's so cool.
I think there was a lot of focus on like going to college and finding out what you want to major in. And I never really got the advice to look towards trades. And I would have liked that. Yeah.
Did you work a lot of other jobs outside of high school before you did the security job?
I did mostly like food service, security for about 3 or 4 years. Yeah.
Before you started here.
Mm-hmm.
Are you enjoying it? You really like it?
Oh yeah, it's a great job.
Yeah, this is your thing.
Mm-hmm.
So my name is Travis Cole. I am a operating engineer here at Fred Hutch. Started out as an apprentice, went through the whole program, and it's been about 7 or 8 months since I graduated out of that. So it's a 4-year program. You normally go to class Monday and Wednesday evenings after work. So it makes for some long days, but the union pays for the classes, and so does Fred Hutch. So it's an awesome opportunity. You're not in debt when you're done. You've got an amazing career. You're already vested in the union by the time you're finished. It's just a really good way to get started, especially if you're not too sure what you want to do. This is a nice way that you still earn money while going to school. So out of high school, I joined the Navy. I was in the Navy for 5 years. I was a nuclear machinist mate. So I got out in 2011. I've had a myriad of jobs between now and then. I did everything from insurance sales to upgrading Doppler radar systems. There's a lot of time of just trying to figure out what I wanted to do and how I wanted to do it. I've found a solid career, solid people to work with, and I mean, I've got the training where this job is applicable pretty much anywhere. So it's not just for the Hutch. This translates into hospitals, data centers, office buildings. So it's a good career just to have and a good skill set. So through the apprenticeship, you go through all the groups. So you get an idea of how to do all the jobs around here, which is amazing. It makes you more versatile and you can respond to anything. But however, you do end up in a specialized shop. So I have ended up in the electrical shop. So we work on all the lighting systems, all the generators, we do all the runs. We oversee the maintenance on them. All the electrical distribution system we work on, all the way down to outlets and surge protectors. Okay, so this is one of, I believe, 5 emergency generators we have on campus. So this is going to provide us with emergency lighting, some heating and cooling abilities. It's going to power the freezers in case of a power outage. And that's really our main concern, is we want to maintain building safety, human life, and viability of research. So this allows us to be able to do all 3 with allowing lighting so people can exit the buildings. And then this is just also peace of mind. We don't have to worry about snowstorms, windstorms. We can sustain ourselves for a few days while everything else gets settled out. So on a daily basis, we have different PMs, so preventative maintenance that we do. That's just to make sure that our equipment's running. It identifies any future problems we might have, so that way we can plan for a fix instead of reacting to a failure. We also deal with customer complaints. So let's say your lights go out and we change the bulbs don't work. We go in and we figure out what's actually wrong with it. And then we're here for emergency response. So flood, fire, a major failure of any component, we're able to react, which is why we're here 24/7, 365. Very loud.
Very loud.
Very, very loud. Yeah, you definitely don't want to be in here without hearing protection on when it's running. So this is a motor control center. So what it does is it starts and stops a lot of our pumps and fans, and it gives us a good way to where we can safely de-energize stuff so we can work on it. So this is our main switchgear room for phase 1 and phase 2. So city power comes in the room next door, which we don't have access to, only Seattle City Light does. It comes in here, goes through all of our main breakers, and then we have our automatic transfer switches right here. So what these do is in case we lose power, these are what will start the generator, and then it'll switch over a physical switch, like your light switch at home, to the emergency power to feed the building. So it's called arc flash suit. So if you ever have experienced like a static shock, that little jump of electricity, these will do that, but a lot more, to the point where it will vaporize metal. So you have to be very careful. But these are the suits that you have to wear when you deal with some of the stuff. Just fire retardant, just protects you from getting burns, anything like that. And then you also have to wear a helmet. So it's tinted so you don't get blinded by the arc. And then it also protects against any molten metal that might come in your face, and also the shock wave and heat and stuff.
So that's in case of a catastrophic failure, pretty much, or something.
Just arcing.
Just arc?
Just arcing.
Does that happen often?
Not here, but in the field it does happen. Yeah, so it has... So when you're fully gowned up, you have no skin visible. Because you also have to wear rubber gloves and then leather gloves on top of the rubber gloves. It gets very hot, very fast. So for a career like this, I would look into apprenticeships. I mean, it obviously helped me a lot. I don't have student debt, don't have to worry about it, which is awesome. Also, you're still young. You don't know. Like, it took me 5 years between the Navy and here to figure out what I wanted to do. And sometimes you just gotta try stuff.
My name is Dennis Ergens, and I'm the power plant lead here at Fred Hutch. On a daily basis, I'm the lead, so I make sure my guys have work and parts and maintain all these boilers and chillers. So I'm the kind of the point guy for it. I don't do a lot of mechanicking these days. I'm mainly here to pass on my knowledge and make sure the guys have everything they need to make sure that they get their jobs done correctly. Actually, when I started here, I had never done building maintenance before. So I was a contractor doing stainless steel, what they call sanitary piping for food plants and breweries and stuff. So I had a lot of experience working in plants as a contractor, but never actually been a maintenance guy. The apprenticeship program we have here is really great. If I would recommend something to somebody, I would recommend that. If you want to get in the trade, get into the apprenticeship program. Because you're getting hands-on training. You're working here just like anybody else. And you're also getting the classroom training from the union. And so, we are really happy with every apprentice we've had has just been spectacular. They make really well-rounded OEs, so it's a really good way to go.
I love this ductwork. It's just amazing.
Yeah. We actually have a little RC car that we can put down it with a camera. Yeah. Well, our old controls guy came up with that idea because sometimes stuff will get stuck in there, and it's hard to see in there, obviously. So we just send this little car down there. Yep. Yeah, these are the Siemens controllers for our control system. And these are the pneumatic controllers for the control system as well. You can see all the air lines and solenoids and relays and gauges. And another cabinet of them. Everything nowadays is not pneumatic. This is older stuff here, so. This is a newer cabinet here versus one of those, you know. But this is how we get to see all our equipment, you know, via the EMCS, is through all this stuff. Wires everywhere. But it makes it nice to be able to sit in front of a computer and see everything on your campus. If you're interested in something, pursue it. You know, even if you, like for me, I don't have a college degree. I went to a little bit of college, you know, to do welding. We pay extra for certain licenses, you know, to have, like a boiler license, reefer mechanic license, a welding certification. It also makes you more valuable, you know, when you're going out to get a job. The key one is the boiler license. If you want to work in maintenance in the city of Seattle, you need that boiler license. That is your ticket in the door to get a job. Right now, our starting salary for OE1, I think, is 42 and change an hour, which is pretty good. So wages are just, for us, you know, we're in demand and wages are just going up. You know, where most markets are going down, you know, our demand is gone up. So is our wages. So.
Job security.
Yes. Good trade to get into. I make, you know, a lot of people poo-poo, you know, oh, you're a maintenance guy, you don't make nothing. You know, I made over 100 grand last year being a maintenance guy, so it's nothing to sneeze at. You know, it's not like you're going to be a low-paid person. It's definitely a living wage, so, you know, it's well worth having a career in this field. Or in any other trade, you know, electrician, you know, plumber, fitter. In fact, we all are. They got us split in specialized groups here right now. We're all expected to be well-rounded OEs and be able to do pretty much anything. But like me, I specialize in the boilers and the chillers. We have an electrical crew that specializes in electrical. And then we have the lock shop who specializes in locks, obviously, and the carpenter shop. So yeah, you're expected to come in as an OE, well-rounded OE with a specialty. When I got hired here as an OE. My specialty was welding. So, but now I've kind of progressed into this being the lead in the boiler plant. I would encourage everybody, if you're interested in something, just to pursue it, you know. And hopefully the high schools these days have these classes for you, these trade classes that you can take to get you started out.
A lot of people are focused on going to college, okay? We pay a really good salary here, okay? Once you're an operating engineer, more than a lot of college grads are making. So this is a really solid profession, but I'm going to make also a pitch for the Navy, the Army, the Air Force, and the Marines, okay? Because those are also great places to start. If I was coming out of high school and I wasn't sure what I wanted to do, I'd seriously think about joining the military, okay? You get 4 years, you get a lot of great training, and you get paid while you're doing it. I started out in the military, and it worked out really good for me. So the apprentice program is a really, 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 really hard program, okay? You have to be in the program for 4 years. You take approximately 2,000 hours of classes on your own time during these 4 years, while you're also doing a full-time job here. So it's like working 2 full-time jobs, and the pay is pretty good. You start out at 65% of the OE1 wage, okay? And then you progress in 5% increments every 6 months until your 4 years are up, at which time you're fully accredited as an OE1. Yes, as you get more licenses, your pay can increase, okay? And as you get more time in the plant, your pay can increase. But as you get more licenses, and the apprentice program will help you get 1 or 2 licenses, you can increase your pay there also. The 302 union has their own set of classes that they're training the people on, and they have their own training center down in Renton, or Auburn rather, I'm sorry, in Auburn. But there are, in joint partnership with that program, is Renton Technical College, and there's some classes that you take at Renton. When you're on the team here, we try to move you around about every 6 months to a different team here on site, so you get a well-rounded education. And that includes, you know, the refrigeration team, the power plant team, the controls team, the electrical team, the mechanical team, even the architectural team. So you get a lot of experience in a lot of different areas and what have you. And if you're real interested, I suggest you go to the 302 International Brotherhood of Operating Engineers 302 website, and they've got more information on that. They say there's a graying of the trades, and what they mean by that is a lot of the people that are in the trades right now are aging out. So we've got less operating engineers in the future because of the massive retirements, and more need for operating engineers because of all the building that's going on. So it's a great, great field, I think, to be in. And it's a field that, you know, isn't going to be shipped out and sent overseas. You know, you can't move being an operating engineer overseas.